So let's look at one business service in particular and see how the event which causes it to turn orange affects that particular business service and the components which make it up. So drilling into USE payments, we can see the topology of that particular business service, an IIS server, SharePoint, SQL Server, which then ultimately stores its data out in a NetApp storage environment. On the right, we can see the impact tree, fairly detailed, which lists out every single component of every major application and server shown in the topology tree. There's quite a lot shown over here, and there's no need to actually scan through the entire thing to figure out what's wrong. Simply by clicking the root cause button, all the non-relevant items will be filtered away, leaving just those items that are in some sort of alarm or problem condition. Now, let's go back and see how we would do this without the root cause button, and let's use that to explore some of the features that are exposed by this service map. The service map, of course, is discovered by the software, by the tool automatically, and it's updated on a continual basis so that you know this service map is not only up to date but updated in very near real time. So if we pick the component in question, the SQL Server, and look over on the right, we can see all sorts of attributes which the discovery process and the rediscovery process, for that matter, have learned about that particular component. So first up, we can see the application. We can see, yes, it's SQL Server. We already knew that, of course. But we can see the installation path, the instance ID, the version number, service pack level, so on and so forth. So if I'm troubleshooting this, maybe I find that the version is out of compliance with what's required for my organization, and I need to upgrade it or perhaps apply a service pack. And I can see that information right here, right away, without navigating anywhere else. I can also see which server is hosting the application. Again, which server is hosting SQL Server in this case. And I can see, for example, here that it's SQL Server 01 with a certain IP address and host name and so on and so forth. I can see serial numbers if I need to perhaps use that to create a trouble ticket and remedy. But more importantly, I can see which VM is actually hosting the server itself. And again, I have all the appropriate attribute information there for raising tickets or doing troubleshooting sorts of activities. And then, of course, following the chain on down, we can see which hypervisor is actually hosting the VM. So we see the entire chain, application to server to VM to hypervisor. In fact, ServiceWatch is tied into vCenter on an API basis. It's directly tied in, so that if vCenter moves this VM from one ESX host to another, vCenter will notify ServiceWatch, and should that cause this map, the service map, to change, then that change will be propagated automatically without any human intervention, without clicking on any buttons. The map will be updated. But so let's say we've gone through all these attributes. Let's say they all check out fine, no problems, everything's good, at least from the point of view of the attributes on the SQL Server, but we're still trying to troubleshoot the problem. Let me show you how we can drill into more detail on this particular component. I might look at the upstream connection. I can see, if I click on that, I can look at the network path and see that, in fact, in this case, the SQL Server is hosted on an ESX, a physical ESX host, along with the source connection, the source server, MO2 here. And since I asked for the network path and it only shows me the ESX host, that tells me that we're using, in this case, the virtual switching services of the ESX to move data between these two virtual servers. So that's interesting, but no red alarms indicate any kind of problems there. So I can look at the downstream path as well. And in this case, it's actually called a storage path because not only is it a network, doesn't show network infrastructure, but also shows storage infrastructure as well. And in this case, we can see at the top, we can see the SQL Server riding on an ESX host and the NetApp storage environment. That's our destination down at the bottom. But in the middle, of course, this is the thing we're after. we can see that the way it gets to, the way traffic is moved to the storage environment is via this particular 3-COM switch. And again, we can see relevant attribute information here, but I see no red alarms, no red ports or interfaces, so everything checks out okay here. But let's look at something that the discovery process found that's really interesting to me, and that is that the C drive in the storage environment is mapped over to volume 3. In the, I should say, the C drive on the server is mapped to volume 3 in the storage environment. So what that tells me is that the original error that we saw about free space being down on drive C is really free space being down on volume 3. So why are we going into this? Well, these service maps are kept up to date in real time, and these events are brought in real time, and they're correlated against the service map. Remember, let's look back at the original topology. We can see that the server was the one that had an orange alarm associated with it. So in this case, we can directly see that there's one component with a problem. The events told us that. The events pinpointed where this component lies in my overall service map, and I see that there are no redundant or alternate servers for the database functions. So if this thing goes down or has a problem, it's going to affect my service. In fact, it might take down all of the US e-payments business service. So it's pretty important we keep this thing up and running and take a look at what the problem is. So what we're doing with Service Watch and the event integration to a real-time updated map is we're helping identify the root cause problem the first time, the right time, with the right person the first time. So this means that since we've identified that the NetApp area is the problem source, we can call the NetApp admin over, have them allocate more room to volume 3, and the problem will be fixed. Instead of the usual siloed management approach, which so many people still use, and that is, you might call the server admin over. Oh, well, maybe the database is creating some unnecessary files or something, so let's call the DBA in to look at the same server. Maybe since drive C is hosted on the NetApp, oh gee, it could be a network problem, so let's call the router or the switch admin in. So all of a sudden we have 3 or 4 different experts working on what's really a storage problem. So the integration of events to, again, an updated map helps alleviate that problem of figuring out which siloed expert is the one to tackle the problem. We can pinpoint the cause right away, again, the first time, and have that person be assigned based on a combination of the events and alarms integrated on these service map screens.